Hi guys, it's Mr. T again. This video, we're going to introduce the second unit on quadratic functions, equations, and relations, just in general, but we're going to mostly just do a quick introduction of that and then work on module 3, which is focused on quadratic equations, and just do the first part of 3.1 as we start the introduction of solving quadratic equations. We're going to be talking about just that first piece of it, and then we'll do a part 2 for the other half. Okay, and I'm just going to get rid of my face today and focus on these other things. Okay, so this is the beginning of our unit 2, or quadratic functions, equations, and relations. And in the book, we're going to be kind of walking through some of the things there in the actual textbook that we use this year. It's on page 109, and they have a nice little cute little thing here about toy manufacturers. You got all these cute little stuffed animals, and they talk about how math is an important part of this industry, and it is. I mean, there's so much that goes into it to make sure they're staying profitable. Watching the trends and of what's going up and down, three-dimensional modeling, just making sure they're using the best that the material that they're cutting out for these things is the most efficient they can. Lots of stuff that goes into that, and numbers that really make a difference in that. And just not only this industry, but in others that are very similar to it. Just try to give you an idea that hey, this math is something that and used in the real world, and here's an example thereof. And always encourage people here, um, like even in the toy manufacturers, working in line is a good, honest trade there and good work. But if you want to move up, you're going to need to be able to have a little more experience and education and know what you're talking about in these areas. If you start off with some little bit better education, a little bit better, and math being a piece of that, the more likely you have of getting moved up sooner, and that kind of thing. So, but always fun to see that even in the toy industry, you're seeing where math can show up. So that kind of introduced with that idea there. But we're going to move on now to talking about quadratics, and our focus attention is going to really be is how can we solve quadratics? Okay, and we're going to look at several different methods for that. Voila, finally we got there. Quadratic equations, okay? And look at this. So how can you use quadratic equations to solve real world problems? And we're going to look at 6 different ways to solve quadratics. We're going to focus on 4. And the last one is solving quadratic equations taking square roots, which is really a misnomer because it's really by graphing, square roots, and factoring. Okay, and they introduced the idea of imaginary numbers, which is the basis of a complex number, and then we'll move on from there. So let's go on into this solving quadratic equations through taking square roots, graphing, and factoring. But before we even go there, I do want to jump back to section 2 here that we covered previously. Where'd you go? There you are. If you'll remember, back in section 2, solving absolute value equations, we had this situation here, and we said, what do? We're going to take the left side of the equation and put that in y1 of our graphing calculator, and put the right-hand side in y2. We're going to graph both of those and notice where they intersect and then calculate those places of intersection. And so we did pretty good with that. And so in this case, it'd be 2 and A. My question to you is, would it be different if instead of a V shape, we had a U shape like a parabola? No, it wouldn't be any different at all. The equation would be different, but how we would work it? No real difference at all. So we already have the basis to be able to solve a whole bunch of things, whether it be quadratics or cubics or anything else. So any kind of polynomial would be, we can solve that by using this method. So we already got the basis we need for this information. But they're going to go through just a quick refresher on some 3 different basic methods. And I'm going to take the graphing and expand it out a little bit further. Oops, a little too far. So let's look at our first equation here. We got solving by graphing. So we're going to graph the left side and the right side. Okay, back. So finally got my calculator to come up. So what we're going to do, we're going to hit y equals. I'm going to hit x and then the square button. Then I'm going to hit zoom down here to standard, which is 6. Take a look at that. Now, in our equation, it's x squared equals 16. This only goes up to 10. So what we're going to do to be able to see up there around 16, we're going to come over here, hit the window button, and instead of going from -10 to +10 on the y, we're going to come on down here, and we're going to make that -2, and let's say 20. Okay, next lunch. All right, so let's now look at the graph button because I don't want to change my settings. So there's the guy there. So there's the deal. And then I can go back and put in my, to the next one here. Whoops, got a little crazy there. Let's put in 16. Look at the graph again. And so that is what that's going to look like. Well, then we need to translate that over to our paper. So how are we going to do that? Well, let's hit second graph. And that gives me a whole table of values, right? A whole table of values or points that we can graph. So let me get, well, there we go. And so 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. So I'm going to minimize this so I can jump back over into where we were before. Well, here we go. So what were those points? One more time. There we go. So we said the points were 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16, and 5, 25, which will be way up there somewhere. Okay. And then I can go back and put my other points from my table, or I can just mirror image it, which is called symmetry, right? Because this has symmetry, and this being the axis of symmetry for us. And so now we play connect the dot. When it's time for graphing, we always dots first, lines second. Play connect the dot afterwards. It's not, there's a time for sketching, and this is not it. Okay, not the time for sketching. So here we go. So we got that graph in there, and then we can put in the 16. Okay. And so to solve by graphing, you're going to graph the left, that's the parent function in this case, and then graph the right and see where they cross. And we can calculate that on a calculator, but it's pretty straightforward, isn't it? It's just going to be x equals what? -4, and then x equals +4. Okay, isn't that what those two spots are? And so -4, +4 is what their solutions would be. And remember, when they ask you to solve by graphing, if you do the graph, that's great. But if you don't draw these arrows and write x equals, you haven't done the solving. You have to tell what the answer is, or you haven't done the solving. So let's take in this basic simple quadratic and solve by graphing. Next, they come up with solve by factoring. Okay, so let's take this same problem. We already know what the answers are going to be. That helps us out there. And so they want to solve by factoring. So they start off with this same situation here, and x squared. But to solve by factoring, the first thing we have to do is make sure it's equal to 0. So we're going to subtract 16 from both sides of our equation, and that gets us x squared minus 16 equals 0. We notice that there's no, to factor, we got to check for greatest common factor. There's not. There's two terms, and we use our little graphic organizer to help us remind us when we have two terms, they're both perfect squares with a minus. That's called a difference of squares. So I just take the square root of each, and that gives me x plus 4 and x minus 4, because I got to have the different signs if they're going to cancel out for later. Take each factor, put it equal to 0, and then solve, and then there's my -4 and 4. So that's the basics of solving by factoring. You factor first, put each factor equal to 0, and then solve from there. Again, we have the same answers. The next, whoops, but before we move on, before we go to taking square roots, I want to stop for just a moment and do let's graph this equation and see what happens there. So in this case, I am going to do a sketch, okay? Because my coordinate plane that was up before isn't really set up for this as well, okay? So 1, 2, 3, 4, 5. That's good. 1, 2, 3, 4, 5. All right. And we got some things here, and I'm going to label that one right down there as negative 16. We'll see in a second why. Okay. Now, to graph this, it's the same as the one above it, except what? It's been moved 16 down. And that, remember our vertex form? That minus 16 would take that vertex and move it down 16. So our graph is going to start here, and it's going to go up, and we can pass through these places here. And so without getting too crazy with it, this is what we would get. Okay. Ooh, that's a terrible sketch. But the point of this is what? That is x equals negative 4 and x equals 4 right here. So when you set it equal to 0, we're now looking for where it crosses the x-axis, and that's one of the things that's important for us. This is the more normal way we're going to be solving quadratics, is when they're set equal to 0. But this works just fine, taking it just like it is, not making it equal to 0. But more often than not, you're going to have it equal to 0 or close, and you're going to be looking for where it crosses the x-axis. So this is still solving by graphing. It's just setting it up equal to 0 first. Okay. Then the next method is to solve by square roots. Whoops. Wrong button. There we go. Solve by square roots. So let's slide down here. Okay. And the idea here is we're going to try to get this square by itself and then just take the square root. Well, they didn't have a lot going on here. They already have the square, so they took the square root of both sides. Okay, so cancels out here, leaves you just plain x, gives you plus or minus. When you're doing square roots in an equation, you have to do the plus minus. And then the square root of 16 is just plain old 4 here, easy enough. Okay, so you get your plus and minus 4. So you have 3 methods, okay? All of them give you the same answer. It just depends on your situation which one. So we're going to do some practice with all of these methods so that we can be prepared no matter what the situation is. One thing I do want to mention though, taking square roots, it's all well and good. However, if you have in the standard form, meaning when you have standard form ax squared plus bx plus c equals 0, okay? That's standard form. If you have a bx as part of your problem, solving by square roots is not going to really be your best choice or even an option. That's where complete the square kind of comes in. But as long as this is not there, solving by square roots is a pretty good deal. Okay, but if it's there, don't even try. Can't happen. Okay, so there's 3 quick examples. Let's look at a few more things that the book here has given us. Okay. Well, here they go into, to solve by square roots, they do a review on simplifying radicals, or square root in this case, and refreshing our memory that, of course, you would leave that as 2 times the square root of 3, or 2 on the square root of 3 is how you would say that. Okay, not a decimal. That's not the same. And then if you have a fraction, and you can't get to 3 here, but they also go to much further. You can separate those, but if you get something like a square root of 7 in your denominator, you have to do what's called rationalize denominator. We're not allowed to leave a square root in the denominator. And so they go through this example here. So that'd be a whole separate little issue, but there's a quick little refresher. And if not, then you need to go back and do look up on how to rationalize the denominator. Okay, got a couple more examples here of taking square roots. Got a little bit more to them. So we got 2x squared minus 16 equals 0. So my question to you is, what would you do if the square wasn't there? Well, you would probably do what? Add 16 to both sides. Okay, here we go. Then what? Divide by 2 on both sides. That's probably good. So those steps didn't change one lick, not any at all. Now we do, but the square is here, so we do have to deal with it. So what's this? So how you get rid of squares? Square root. Okay, and so we took the square root of both sides. So square and square root cancel, leaving just x. So now we got to break down this square root of 8, which is square root of 4 times square root of 2. And that turns into plane 2 and then square root of 2. So that is the answer. A very, very good answer. Okay, we can plug that into either one, the positive or negative, and that would end up turning out to be 0. Very good. Now, something I do want to mention here is just to show you a different option here. What if it looked more like this? Let's do a plus 4 minus 12 equals 5. We'll just try 5. How about that? All right. So, well, I take that back. Let's leave it 0. Okay. Well, do you see a difference between these two things? Do you see a difference? Let's just make it a 3 to have fun. They're essentially the same thing. They say, no, they're not. Well, sure they are. This is a number times something squared. Well, this is a number times something squared. Then minus a number. Minus a number equals 0. So essentially, they're the same. So how would I work this problem? Well, the first steps are going to be exactly the same. We're still going to add the 12, just like we added 16. So that would give you 3 times the quantity a plus 4 squared equals 12. Okay, what do we do next over here? We divide it by 2. Well, we're going to divide by 3 here. We're going to divide by 3. So it cancels there. So you get a plus 4 squared equals 4. Easy enough, okay? But now we can't subtract 4 because it's inside the parentheses. But we have gotten the square by itself. So now we're able to keep going further by taking the square root of both sides of the equation, okay? The square and the square root cancel, so whatever just in there plops on out down to the next line just like it is. Don't worry about what to do with it. Just rewrite it first. And oh, we got lucky on this one. This is going to be just plus or minus 2. Okay. And then subtract 4 from both sides. And we end up with a negative 4 plus or minus 2. That means we're going to do negative 4 plus 2. Okay. So what's negative 4 plus 2? Well, that's negative 2. What about negative 2 minus 2? Well, that's negative 6. So you'd get those two answers. So just a little bit different way to look at it. And then they knock these out as another example here as well. So encourage you to try these two on your own. I think we're going to stop right there for today for this video and pick up with these other guys on our next video. The word problem is pretty straightforward. Let's scoot down here real quick. Okay, so what you're going to do on the first couple of problems is just like we did the first example. You're going to take it just like it is and graph it. So you'll have your parent function move down by 2. Going to come across on your 7. Tell me where they cross. Then you're going to put it equal to 0. Factor out your 2. Um, I'm sorry, you won't factor out your 2 there. That's the next problem. But you'll be able to factor that and solve it and get your same answer. Then you can also just add 2 to both sides and take square root. You're good there. So it's taking the same equation, doing it 3 different methods. You should have the same answers, right? And so give this a practice. So the full assignment is going to be starting on this page, which is page 120. We're going to be looking at 1 through 21, okay? So for our practice, it'll be 1 through 21, skip 22, and then do 23, okay? So starting on page 120. At least give that a try. You could be able to do many of those, and then I'll do a second video, and you should be able to do the rest, okay? Hope that's helpful. Good day.